1971, Apollo 15 astronauts conducted a famous experiment on the moon. Here's a bit of the original recording.
Well, in my left hand I have a feather. In my right hand a hammer. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct.
Actually, no. Mr. Galileo was not correct. What the astronauts should have said is, Mr. Galileo was wrong. According to Galileo, the moon has an atmosphere like the Earth, so the feather should fall more slowly, just like it would on Earth. Galileo even claimed that it is obvious that the moon has an atmosphere. Obvious. That's the word he uses. This is in the Sidereus Nuncius, one of his famous published works. It is obvious that not only the Earth but also the moon is surrounded by a vaporous sphere. Those are Galileo's own words in this famous work. So if the astronauts wanted to test Galileo's theory, they should not have dropped the hammer and the feather. They should have taken off their helmets and suits and tried to breathe. That would have showed you how right Galileo really was. But okay, let's put the issue of the moon's atmosphere aside. So heavy objects fall as fast as light ones if we ignore air resistance. So that's the principle underlying the experiment. We are often told that this is one of Galileo's most fundamental discoveries, and he supposedly destroyed the Aristotelian theory of physics on this matter by simply dropping some objects of different weights from the Leaning Tower of Pisa. And this was allegedly an eye-opening moment in which the world realized that empirical science is more reliable than philosophy or the words of ancient authorities. So goes the storybook version. Let's see how much truth there is to those things, if any. Galileo indeed often portrays himself as defeating obstinate philosophers who rather cling to the words of Aristotle than believe empirical evidence and experimental demonstration. So he imagines his enemies to be saying things like, "You have made me see this matter so plainly and palpably that if Aristotle's text were not contrary to it, I should be forced to admit it to be true." That's a quote from one of Galileo's dialogues. Galileo likes to pretend that his enemies are like that. It makes life very easy for him. In reality, Galileo's anti-Aristotelian polemics were directed only at straw men. Galileo concocted these caricature Aristotelians in order to let them play the buffoon in his dialogues and thus enhance his own image in the eyes of his readers. These are quotations from one historian who puts it well. Galileo's ploy was well calculated. It tricks many of his readers to this day into believing the fairy tale. Galileo, the valiant knight, single-handedly fighting for truth in a world beset by dogmatism. But excessive claims for Galileo the Dragon Slayer have to be muted, as one overly diplomatic historian puts it. Such ridiculous characterizations of Galileo should not only be muted, but actively reversed, in my opinion. This is clearly seen in the case of that famous question, do heavy objects fall faster than light ones? Aristotle had indeed answered yes. Twice as heavy, twice as fast. That's Aristotle's own rule. And legend has it that Galileo shocked the world when he dropped some balls of different weight from the Tower of Pisa, and he revealed then that they are falling at the same speed. But the notion that it required some kind of radical conceptual innovation by a scientific genius like Galileo to realize that you could test it by experiment is ludicrous and idiotic. Of course, one can drop some rocks and see if it works. I mean, that much had been obvious to any fool since time immemorial. In fact, Philoponis, an unoriginal commentator, had clearly and explicitly rejected Aristotle's law of fall by precisely such an experiment that's more than 1,000 years before Galileo. This is just a plain fact. We have the source of that author. So if you want to believe that experimental science and empirical verification was a radical new insight, then this puts you in quite a pickle. If that was a revolution, then why is it found for the first time in this extremely mediocre commentator from the 6th century? If these people had the key to science, then why did they sit around and write commentary upon commentary on Aristotle? Their contributions to mathematics and science is otherwise zero. Now, do you really expect anyone to believe that the principles of scientific method escaped the many first-rate minds of the age of Archimedes and people like that, only to be discovered by these utter nobodies in an age of vastly incomparably lower intellectual quality? How likely is it that such elementary scientific principles eluded generations of the best mathematical minds the world has ever seen, only to be then discovered by derivative and subservient thinkers in an age where the pinnacle of mathematical expertise extended little further than the ability to multiply three-digit numbers? It doesn't make any sense. So, yeah, that's a proof by contradiction that testing things empirically was never a revolutionary idea. It's a trivial idea that any fool has always considered obvious. Indeed, Galileo was far from original in his own age either, for that matter. Have you ever heard anyone calling Benedetto Varchi the father of modern science? And yet, here is his statement of Galileo's great insights, expressed 2 decades before Galileo was even born. I quote, "The custom of modern philosophers is always to believe and never to test that which they find written in good authors, especially Aristotle. But it would be both safer and more delightful to descend to experience in some cases, as for example in the motion of heavy bodies, in which both Aristotle and all other philosophers, without ever doubting the fact, have believed and affirmed that according to how much a body is more heavy, by so much more speed will it descend, the test of which shows it not to be true." All of that is a quote from a run-of-the-mill humanist writing in 1544, long before Galileo. That just goes to show what an obvious idea it was. So it's not clear historically whether Galileo did in fact carry out such an experiment from the Tower of Pisa when he was teaching at the university there. So legend would have it that he did, but what are the historical record is unclear on this matter. Personally, I find the story plausible, since a field day throwing rocks, that would surely have a considerable appeal to a professor who wasn't very good at thinking, as we have established. But be that as it may, it is in any case perfectly clear that many people carried out such experiments around that time, independently of Galileo. Simons de Wint, for example, in the Netherlands, certainly did and published his results years before Galileo ever made his experiment, if he ever did. And de Wint, he used lead balls of different weights. He dropped them from a height of 30 feet. On the ground, he put some metal sheet or something that would make a lot of noise, so you could hear whether they bang down at the same time or not, these objects that he dropped. So that's another, just like we've seen before, is another way of avoiding the need for stopwatches or high-speed cameras or such things. Instead, you rely on your natural hearing, which is pretty good at making that discernment. And Simons de Wint, he was not the only one. In Paris, Mersenne, he was doing the same thing. He was dropping weights from Parisian chamber windows before he ever heard of Galileo. And here's an amusing quote from the historian Butterfield. "To crown the comedy, it was an Aristotelian who, in 1612, claimed that previous experiments had been carried out from too low an altitude. In a work published in that year, he described how he had improved on all previous attempts. He had not merely dropped the bodies from a high window, he had gone to the very top of the Tower of Pisa. The larger body had fallen more quickly than the smaller one, and the experiment, he claimed, had proved that Aristotle had been right all along." That's the end of that quotation. In fact, Galileo himself once cited another Aristotelian philosopher who also conducted experiments of this type. So in order to investigate whether lead falls faster than wood, we took refuge in experience, the teacher of all things. That's a quote from this author. And hence, we threw these two pieces of equal weight from a rather high window of our house at the same time. The lead descended more slowly. Not only once, but many times we tried it with the same results. This is a work from 1575, well before Galileo. So much for Aristotelians hating experiment. On the contrary, appeal to experiments were commonplace well before Galileo in these circles. And so you might say, well, these guys, they got the result wrong. And maybe they didn't experiment at all, or maybe if they did experiment, they messed it up somehow. So they shouldn't, we should dismiss them as for the scientific contribution. Well, Galileo messed up as well in the same manner. You remember how he got it wrong when he was investigating the area of the cycloid, and it's the same with falling bodies. He also got that wrong at first. In his earlier notes on this, he writes, this is a quote, "If an observation is made, the lighter body will, at the beginning of the motion, move ahead of the heavier and will be swifter. But if the fall is long enough that the heavy body, the heavy body will eventually overtake the lighter one." So Galileo, he devotes a full chapter to following this up, in which, in his words, the cause is given why, at the beginning of their natural motion, bodies that are less heavy move more swiftly than heavier ones. So clearly, dead wrong according to modern theory, according to so-called Galilean mechanics. And yet, when Galileo started these experiments on this subject, he got there's not only the result wrong, but also he believed himself to have a good theory explaining those false results. Now, of course, we know that the true cause for the erroneous result is not a theoretical one like Galileo imagined. More likely is a more pedestrian circumstance. Namely, we are not very good at dropping objects from both hands at the same time. Modern experiments show that people tend to drop the lighter object sooner, even though it feels as if we have dropped both objects at the same time. This is why Galileo and others ended up thinking that the lead ball, it starts out slower at the beginning of the fall than the lighter body, and only then it picks up speed and overtakes it further on. So with experiments being this inconclusive, it's no wonder that Galileo relied on a theoretical argument in his published account. His supporters would have us believe that Galileo showed that Aristotle's rule could be refuted by logic alone. His argument is supposedly a splendid and incontrovertible model example of cast iron reductio ad absurdum reasoning. Those are quotes from Galileo scholars, and they're all wrong. Let us quote the argument from Galileo. It goes as follows. "By a short and conclusive demonstration, we can prove clearly that it is not true that the heavier movable is moved more swiftly than another less heavy. If we had two movables, whose natural speeds were unequal, it is evident that were we to connect the slower to the faster, the latter would be partially retarded by the slower. But the two stones joined together make a larger stone. Therefore, this greater stone is moved less swiftly than the lesser one. But this is contrary to your assumption. So you see how from the supposition that the heavier body is moved more swiftly than the less heavy, I conclude that the heavier moves less swiftly. From this we conclude that both great and small bodies of the same specific gravity are moved with like speeds. And furthermore, if one were to remove entirely the resistance of the medium, all materials would descend with equal speed." That's all the quote from Galileo, his celebrated argument. So with this argument, Galileo allegedly exposes a fundamental logical inconsistency in the Aristotelian theory of fall. Except, of course, he doesn't. Aristotle is perfectly clear. Heavier objects fall faster. So, if you put the heavy and the light together, they will fall faster. The inconsistency arises only if you insert the additional assumption that when you put two bodies together, the lighter one will retard the heavier, slow it down. But there is no basis whatsoever for this latter assumption in Aristotle. It is a fiction that Galileo has made up. Only by dishonestly misrepresenting the view he's trying to refute is he able to draw this triumphant conclusion. Here's a more honest form of the argument, which does not depend on misrepresenting Aristotle. Consider two identical bricks. If you drop them at the same time, they will fall side by side, of course. Suppose you tie them together with a loose string. Well, that obviously wouldn't make any difference, right? Even though they are technically one object now. Clearly that does not impact the fall. And what if you glue them together, side by side, to form a single lump? According to Galilean logic, no reason appears why this double brick of double weight should fall faster than the two bricks tied together with a loose string, or either single brick dropped by itself. So Galileo was aware of this form of the argument. It is in some notes of his, although he decided to use the more dishonest version in his published works. Anyway, what this shows then is that the real crux of the argument is the claim that two bricks held side by side should behave the same way in terms of fall, whether they are glued together or not glued together. And it's not a bad argument, but it's certainly not a matter of logic alone, as those Galileo fans I quoted would have us believe. For instance, imagine you're taking a basketball free throw, and you can choose between trying to hit the hoop with either two bricks glued together or two bricks that are just held side by side as you throw them without being attached to one another. And would you really say that no reason appears why nature should treat these two cases differently, so you might as well go with the loose bricks for your free throw? I don't think so. So why should you accept this assumption in Galileo's case? So if we're being honest, we're back to having to rely on experiments after all, instead of pure logic. The Galileo, indeed, he discusses the experimental side of the matter also in his treatise. He admits that actual experiments do not come out in accordance with his law, because of air resistance, obviously. But he says the fit is much better than for Aristotle's law, and he gives specific numbers for this. He gives exact measurements of how much the slower ball lags behind the heavier one. But it's fake data. He cooks the numbers to sound much more convincing in favor of his theory. The actual lag, or the difference between the two bodies, is more than 20 times greater than the fake data that Galileo reports in his published so-called masterpiece. In no case could Galileo have consistently achieved the results he reported, says one modern scholar who has investigated this. Nevertheless, it does remain true, of course, that Galileo's law, it doesn't fare as poorly as that of Aristotle in this experiment. So yeah, wow, what a hero, the great Galileo. He managed to improve on a 2,000-year-old claim made by a non-mathematician, which not a single mathematician had ever believed, and which Aristotle himself obviously did not intend as quantitative science. Aristotle only introduced his so-called law very passingly, very parenthetically, as a stepping stone towards making the philosophical point that there can be no such thing as an object of infinite weight. There's like one paragraph buried somewhere in the middle of his voluminous metaphysical writings, never to be used again in the works of Aristotle. So Aristotle clearly did not claim or intend his law as a definitive or quantitative treatment of falling bodies. Only later fools who clung to his words like gospel because they couldn't think for themselves, only they made a big thing out of this so-called law of fall. Sort of like some people, they seized upon some obscure remark in the Bible and they gave it all kinds of significance beyond the apparent intent of the original text. Nobody was that foolish in antiquity as far as we know. And as we saw, even people like Philoponis, who were so obsessed with Aristotle, they wrote long commentaries on his every word. Even people like that rejected the law. And in fact, Galileo's discovery is so called that in the absence of air resistance, all objects fall at the same speed regardless of weight. That law is in fact not first stated by Galileo, as so many people believe. Rather, it is first explicitly stated by Lucretius, well over 1,000 years before Galileo. Yeah, Lucretius was correct. Maybe that's what the astronauts should have said. As usual, Galileo gets credit for elementary ideas that are thousands of years old. And for that matter, in his own time too, a number of people discovered Galileo's so-called Galileo's law of fall independently of him. Certainly Thomas Harriot, Isaac Beckman, they had most definitely discovered this law before Galileo, arguably Descartes as well, and perhaps others. So this just goes to show how dependent Galileo is on the framing of him versus Aristotle. No wonder he clings to this and uses it as the trope of his dialogues. Galileo's entire case rests on his readers considering Aristotle to be a great authority. If we admit the truth that Aristotle's law had been refuted more than 1,000 years before, and the ridiculous idea of relying on Aristotle for quantitative science would never have entered the mind of any mathematically competent person, neither in Galileo's time nor in antiquity. If we admit all of these things, then what does Galileo have to show for himself? An unproven claim that doesn't even fit the fake data that Galileo himself has specifically concocted for this very purpose, let alone the many experiments that prove the opposite, including his own experiments, before he knew which way he was supposed to fudge the data. Galileo likes to portray himself as doing the world a great service by defeating the rampant Aristotelianism all around him. The truth is that he's doing himself a great service by pretending that these Aristotelian opinions are ever so ubiquitous. So in this way he can inflate the importance of his own contributions, of the feebleness of which would be all too evident if he had addressed actual scientists instead of these strawman Aristotelians. So I think altogether, with all these arguments, we have done quite a bit of damage to Galileo's claim to credit for his law of fall. But we're only getting started, really. There's plenty more to come, including several major howlers that Galileo made when he tried to apply his law of fall. But okay, that's for another day. Thank you.